फ्रेंड्स चैनल को सब्सक्राइब करो और वीडियो को शेयर करो।
In this video we are going to solve data mining subjective question asked by AKU in 2016 8 SEM exam. These are the questions. Let's solve them. Question number 3E. What is three-tier data warehouse architecture? Explain MOLAP, ROLAP and HOLAP servers. Answer. The three-tier data warehouse architecture is the commonly used data warehouse design in order to build a data warehouse by including the required data warehouse schema model, the required OLAP server type, and the required front-end tools for reporting or analysis purposes, which as the name suggests contains three tiers such as top tier, bottom tier and the middle tier that are procedurally linked with one another from bottom tier, data sources, through middle tier, OLAP servers, to the top tier, front-end tools. Data warehouse architecture is the design based on which a data warehouse is built, to accommodate the desired type of data warehouse schema, user interface application and database management system. For data organization and repository structure, the type of architecture is chosen based on the requirement provided by the project team. Three-tier data warehouse architecture is the commonly used choice, due to its detailing in the structure. The three different tiers here are termed as 1. Top tier, 2. Middle tier, 3. Bottom tier. Each tier can have different components based on the prerequisites presented by the decision makers of the project but are subject to the novelty of their respective tier. ROLAP, Relational Online Analytical Processing, is a model of online analytical processing which carries out an active multidimensional breakdown of data stored in a relational database. Instead of redesigning a relational database into a multidimensional database, this is applied when the repository consists of only the relational database system in it. MOLAP, Multidimensional Online Analytical Processing, is another model of online analytical processing that catalogs and comprises of directories directly on its multidimensional database system. This is applied when the repository consists of only the multidimensional database system in it. HOLAP, Hybrid Online Analytical Processing, is a hybrid of both relational and multidimensional online analytical processing models. When the repository contains both the relational database management system and the multidimensional database management system. HOLAP is the best solution for a smooth functional flow between the database systems. HOLAP allows storing data in both the relational and the multidimensional formats. Question number 3B. How do we transform and reduce the data in the process of data mining? Answer. Data transformation in data mining is done for combining unstructured data with structured data to analyze it later. It is also important when the data is transferred to a new cloud data warehouse. When the data is homogeneous and well structured, it is easier to analyze and look for patterns. For example, a company has acquired another firm and now has to consolidate all the business data. The smaller company may be using a different database than the parent firm. Also, the data in these databases may have unique IDs, keys and values. All this needs to be formatted so that all the records are similar and can be evaluated. This is why data transformation methods are applied, and they are described below. 1. Data smoothing. This method is used for removing the noise from a dataset. Noise is referred to as the distorted and meaningless data within a dataset. Smoothing uses algorithms to highlight the special features in the data. After removing noise, the process can detect any small changes to the data to detect special patterns. Any data modification or trend can be identified by this method. 2. Data aggregation. Aggregation is the process of collecting data from a variety of sources and storing it in a single format. Here, data is collected, stored, analyzed and presented in a report or summary format. It helps in gathering more information about a particular data cluster. The method helps in collecting vast amounts of data. This is a crucial step as accuracy and quantity of data is important for proper analysis. Companies collect data about their website visitors. This gives them an idea about customer demographics and behavior metrics. This aggregated data assists them in designing personalized messages, offers and discounts. 3. Discretization. This is a process of converting continuous data into a set of data intervals. Continuous attribute values are substituted by small interval labels. This makes the data easier to study and analyze. If a continuous attribute is handled by a data mining task, then its discrete values can be replaced by constant quality attributes. This improves the efficiency of the task. This method is also called data reduction mechanism as it transforms a large dataset into a set of categorical data. Discretization also uses decision tree-based algorithms to produce short, compact and accurate results when using discrete values. 4. Generalization. In this process, low-level data attributes are transformed into high-level data attributes using concept hierarchies. This conversion from a lower level to a higher conceptual level is useful to get a clearer picture of the data. For example, age data can be in the form of 20, 30 in a dataset. It is transformed into a higher conceptual level into a categorical value, young, old. Data generalization can be divided into two approaches, data cube process, OLAP, and attribute-oriented induction approach, AOE. 5. Attribute construction. In the attribute construction method, new attributes are created from an existing set of attributes. For example, in a dataset of employee information, the attributes can be employee name, employee ID and address. These attributes can be used to construct another dataset that contains information about the employees who have joined in the year 2019 only. This method of reconstruction makes mining more efficient and helps in creating new datasets quickly. 6. Normalization, also called data pre-processing. This is one of the crucial techniques for data transformation in data mining. Here, the data is transformed so that it falls under a given range. When attributes are on different ranges or scales, data modeling and mining can be difficult. Normalization helps in applying data mining algorithms and extracting data faster. The popular normalization methods are min-max normalization, decimal scaling, z-score normalization. 7. Wrapping up. The techniques of data transformation in data mining are important for developing a usable dataset and performing operations, such as lookups, adding timestamps and including geolocation information. Companies use code scripts written in Python or SQL or cloud-based ETL, extract, transform, load tools for data transformation.
फ्रेंड्स, चैनल को सब्सक्राइब करो और वीडियो को शेयर करो।